Hi, my name is Adi Mavengere and my research interest is in the use of eye movement tracking in virtual reality to determine learner attentiveness. Eye movement tracking emerged in the late 1800s after a French scientist by the name of Javal observed that eyes do not take in information as they move, but only take in information when they are stationary. Javal conducted research, and from that research, he noted distinct eye movements from which he was able to classify fixations and saccades. Saccades are the movements that eyes make. And he came up with a set of 6 distinct eye movements, which are shown in the table. This taxonomy is the same taxonomy we use in the present day. And in addition to the eye movements, in the present day, we'll talk about pupillary movement, as well as the movement of eyebrows. Following the work of Javal, between 1903 and 1907, several researchers undertook experiments to measure eye movements. One of the first was Delabre, who used a mechanical method to measure eye movements. His method involved attaching something to the eye and using that mechanical mechanism to transfer through a string over pulleys to a recording arm, the eye movements being observed. With this, Delabre was able to observe the major eye movements, but not able to observe the smaller eye movements. Invariably, this approach was rather impractical because it didn't allow for the observation of eye movements in natural settings. Dodge and Stratton developed another approach to observing eye movements. Their approach initially used photography to observe eye movements, but they quickly noted that from photographs they were not able to distinguish the parts of the eyes and therefore not able to distinguish the movement of the eyes. So they adapted that approach and started reflecting a beam of light on the eyes and taking photographs to monitor the position of that beam of light reflected from the retina. Judd, McAllister, and Steele further developed this approach. The limitation of Dodge and Stratton's approach was that they were able to monitor eye movements, but only in a linear fashion. With Judd, McAllister, and Steele, their approach also involved the use of light reflected onto the eyes, but it made use of high-speed photography. The approaches developed by Dodge, Stratton, Judd, McAllister, and Steele have been modified somewhat, but are still the basis of the approaches used in the present day to monitor eye movements. We still use photographic approaches, and therefore the work of Dodge, Stratton, Judd, McAllister, and Steele are the foundations of the approaches to measuring eye movements in the present day. In the 1960s, Yabus conducted considerable research around eye movement, and he observed that there should be cognitive processes which enable the eyes to move to track a moving object. He called the cognitive process the system of pursuit. Through the 1970s and 1980s, research focused on attentional processes relating to eye movements. One of the key findings during that time was that the fixation on an area of interest were not necessarily related to attentiveness to the field of interest. In other words, the eyes could be fixed on one place, but the attention be in another place. This was described by Faber as mind wandering. Given these distinct observations about the patterns of movement of the eyes and their relationship to distinct cognitive behaviors, the interest in observing eye movements and relating them to cognitive behaviors grew. 2 distinct areas of study grew, one which focused on areas of interest and the other which focused on eye movements themselves. Research on areas of interest focused on studying where an individual was looking within their field of view and determining what they were attentive to within the area of view based on where they're looking. The branch of research that focuses on eye movements was more concerned about the eye movements themselves and interpreting cognitive behavior based on how the eyes move as opposed to what they are looking at within the field of view. In the present day, both approaches to eye movement tracking are quite prevalent, finding application in different realms. For instance, area of interest eye movement tracking is used in the control and navigation of virtual reality experiences. By the early 2000s, however, Blaszczak observed that research in eye movement tracking was still rather limited to research laboratories due to several factors, which included how complicated the process of observing eye movements was, the lack of expertise in carrying out eye movement research, as well as the lack of training to do such research. An avid researcher in the area, Duchovsky, went on to write a series of books in which he described the equipment used for eye movement tracking and the processes used in that regard. Duchovsky has invariably become one of the notable researchers and authors in the area of eye movement tracking within the domain of virtual reality as well as other media. Prior to the 2010s, eye movement tracking was of interest in human-computer interfaces other than virtual reality, simply because virtual reality technology had not yet reached maturity. Since the late 2010s and the maturing of virtual reality technology as well as eye tracking technology, a significant amount of research began to arise relating to the application of eye movement tracking in virtual reality. One of the main domains of eye movement tracking in virtual reality was the use of eye movement tracking to navigate and control virtual reality experiences. In their research, Moreno et al. Discovered that medicine, biology, neuroscience, marketing, engineering, architecture, education, and training are the domains which have benefited the most in terms of eye movement tracking within virtual reality experiences. Of these disciplines, education and training were noted to have considerably less research work than the other disciplines. In any case, research relating to educational applications of eye movement tracking have been very subject specific and not generalized to gauging attentiveness or learning based on eye movements. That said, eye movement tracking research in education to date cannot be applied across multiple disciplines. It's confined to specific domains. It's with this in mind that my research looks to use eye movement tracking within virtual reality experiences to determine attentiveness of learners to the content delivered within the virtual reality experience, regardless of the nature of the subject matter being presented.